Hello and welcome to a buildingSMART webinar. Thank you for joining. My name is Ra Twilley and I will be your moderator today. Today we have a joint webinar between Esri and Autodesk, which is titled How openBIM Enables Infrastructure, Design and Construction. The speakers are Marc Goldman, Director of Architecture, Engineering and Construction Industry Solutions at Esri, Marek Suchocki, Head of Industry Association Strategy at Autodesk, and David Alvarez, Senior Product Engineer at Esri. Autodesk have been long-term supporters of buildingSMART, dating back to its inception, and Esri have joined BSI for a few years now as multinational members. Both Marc and Marek have been actively involved in the domains and projects and are well known in the buildingSMART community. We are looking forward to hearing about their collaboration on this webinar. The webinar is scheduled to last 1 hour with a short Q&A at the end. The webinar is being recorded and will be made available for replay on our website. I would like to remind you that your phone lines will remain muted for the duration of this webinar. If you have any questions or wish to make comments, please use the chat function located within the control panel. I would also like to bring to your attention that buildingSMART is committed to ensuring that participation in the development of standards is unrestricted, and the process for their adoption is transparent, and standards that are developed do not favor any particular provider and are open, non-binding, and accessible to all. Please take note of our antitrust code of conduct. Now I'd like to hand over to Marc.
Thank you very much, Ra. Let me turn my video on. There we go. Well, thank you again, Ra, for the introduction and the opportunity to present to the buildingSMART community, and I guess probably a wider community than just folks who are members of buildingSMART, on the topic today, how openBIM enables infrastructure design and construction, with professional friends and colleagues, Marek and David today. First, just the least bit of an introduction about GIS. I know that in AEC, GIS is growing in understanding and usage, and certainly the value of GIS. I think a lot of folks still sort of think of GIS as a mapping tool, and many might even think of it as a 2D mapping tool, but it's certainly much more than that. We still develop maps. They've evolved into maps that collect data from field operations, that perform spatial analytics and data science within those contexts, imagery and remote sensing, data collected from satellites, fixed wing, helicopter, drones, terrestrial imagery, that information combined with real-time visualization and sensors, delivering analytics and understanding of contextual environments in full 3D capabilities of all levels of fidelity and quality. The platform GIS serves as a data management solution, and in the case of Esri, we have a myriad of APIs, developer tools, methods of integrating and connecting to our solution. So we like to say that GIS definitely expands the value of BIM, and you'll see that today in our presentation. But we're also turning maps into apps, and those apps enable better decision-making, certainly in the world of AEC. For a little bit of context and history of Esri's investment in and interest in BIM integration, going back just about 10 years, you can see on this chart here, I'm not going to step through every.
Can I just interrupt, Marc? We haven't got your presentation up.
Oh, gosh. Thank you.
Apologies.
I've never done that before, I'm sure. All right. Well,
thank you. That's visible.
There we go. Okay. So, appreciate the interruption very much so. So yeah, so all of these bubbles on the screen here, going back about 10 years, we have been integrating BIM into our GIS platform, our flagship product, ArcGIS Pro. I'll talk a little bit more about that in a moment. The introduction of that platform, that capability of desktop-based GIS in a very modern user interface with BIM importing capabilities, the concept of a scene layer package being added, bringing in Revit direct RVT file importing once we formed our alliance partnership with Autodesk, bringing in the building scene layers, allowing cloud connection capabilities. And in the last few years, a really strong investment and commitment to IFC, importing all the way up to the latest IFC 4.4 Addendum 1. And we've got several people within development, several people within the AEC group, all working to keep IFC front and center in our efforts. And it's not just buildingSMART that we work with to ensure that we are interoperable. We utilize the ODA libraries. We are strong supporters of, members of, participants of the Open Geospatial Consortium. We have many of our libraries available through GitHub for extending our capabilities, integrating with our solutions, white labeling our products, a complete developer program, in addition to all of our support for standards like IFC. We also are strong supporters of CityGML and I3S, and a founding member of the Overture Maps Foundation. So just a quick slide to point out that we, as well as having our commercial software that is commercial business, we are strong supporters of, proponents of open environments, recognizing certainly in the world today, you need to be interoperable with the standards that have come together. I mentioned ArcGIS Pro. This is our platform for bringing together the many layers of content, whether it's 2D map layers, OpenStreetMaps data in 2D and 3D, BIM content, satellite imagery, topographic information. You can see on the screen here just a wide range of content that comes together that can then be analyzed, pushed out to web scenes like you're seeing on the screen. ArcGIS GeoBIM is a relatively new product going on a couple of years now. Through our alliance partnership with Autodesk, we worked very closely together to develop a web application that connects the Esri cloud environment, ArcGIS Online and soon ArcGIS Enterprise, to Autodesk Construction Cloud and BIM 360. So a single web-based application that brings your BIM, GIS, and all of the supporting information, all of the content that you might have either in a GIS environment or hosted in the ACC and BIM 360 environment in a single application, delivering on a lot of the digital twin kind of concepts that we all are talking about these days. And then another application that really is one of the favorites of mine at Esri, ArcGIS City Engine, a procedural modeling, computer-generated architecture application for larger scale, urban-based, campus-based environment creation, navigation, integration into visualization environments that both reads and writes IFC, still at 2.3 on this platform, but we'll be pushing that forward. So with that, I want to show a few examples of how we bring together GIS and BIM, and in particular, openBIM content. This is an application called Story Maps. It's an application from Esri that is used for telling stories, often related to maps. This first example starts out with a scene of San Francisco, and this is not just a static image. This is actually a 3D map of the Bay Area, where we simply begin in ArcGIS. We choose an area of interest, we select a base map, and we save the scene as a slide. Here I'm zooming into the area near the stadium, down along the bay. We've chosen OpenStreetMaps 3D content as a layer. My colleague David Alvarez, who will be jumping in a little bit later, he modeled this simple bridge in InfraWorks and then exported it as IFC, imported it into the ArcGIS environment using our geoprocessing tools. And we can just navigate around the scene, turn on and off some layers, isolate the bridge itself. And this is, like I said, this is a 3D environment. This is not just a 2D static image. This is a full map. And all of the objects that came out of InfraWorks are available with all of the properties. You can see the property values. There aren't a whole lot that were populated in the creation of that bridge, but I'll show you some other examples. Point being, the IFC that's generated in an authoring application exported via IFC, brought into a GIS web scene with all of its valuable information. Here's a scene from Columbus, Ohio that David just shared with me yesterday. I think it was maybe 2 days ago now. And this is Columbus, Ohio, based on 2009 information. And again, this is a 3D scene, river running through Columbus, 3D buildings brought in through the OpenStreetMaps content. Here's that same environment, though, based on 2015 data. You can see the river is much lower, a little bit of development going on along the riverfront. And then a few years later, significantly improved riverfront. And these are satellite images combined with representations of the actual locations of trees and the bridge itself, again, with the properties and information that came from InfraWorks. So we can interact with this environment, we can view these models, we can interrogate their data. I mean, these are just simple examples of bringing IFC data into a GIS environment. I'll show you an example or two that's much more robust as well. This is another example. So this is not Autodesk. This is a company called iStram. Just before the buildingSMART Summit in Rome back in March, I reached out to a company that I had seen online. I saw an interesting 3D model by this company, iStram, asked for them to share the model with me. Here's the model in BIM Collab. Here it is in an Esri web scene that was brought in through that same concept of an IFC authored in a different application, exported as IFC, imported into ArcGIS. Again, different layers turned on and off, the scene view changed, all of the objects available with their properties as you'd expect to see in a BIM, openBIM viewer. Here's a model from Vectorworks, yet another platform for BIM authoring. We asked for multiple IFC files in this case, so we've got the architectural model. Here I changed the view a little bit, turn off some of the exterior elements, some of the surrounding buildings. And just as I scroll through here, the system knows to turn off the exterior, turn off the structural, isolate just down to, let's try to get those mechanical systems back. Isolate down to just the mechanical systems. And yet again, the properties that were created in the authoring application available in a GIS environment for spatial analytics and all the things that you would want to do. An example from Bentley. Another simple example from On-Roads. I asked for an IFC file from folks over there. And here again, we can just simply change the scene. It is a full 3D environment. I can scroll through and jump over to additional predefined scenes that I've created and find all of those properties, in this case of the barrier running down the middle of the bridge, or the tunnel. And this, I believe, was a 4.3 file. And then finally, CSFPEA, a company I ran into in Rome, actually asked for their file when I saw them on the show floor, thought it was a great bridge. This is a 4.0 IFC file, shared it back with David while I was in Rome. He was in the States, and he simply brought the model into ArcGIS Pro, saved a few predefined scenes for me. And again, it's a 3D model in a 3D environment. It's not just a static image, but it's actually a model that I can interact with very easily, proving the point that we are bringing in IFC data of various types of projects from a range of applications very easily, maintaining all the information that you'd expect to see. So those were just, I kind of refer to them as science fair projects, just basic viewers of the IFC content in a GIS environment. I've got a couple examples of customers who we've worked with who are relying on openBIM, combining it with GIS, in particular, delivering insights for construction planning. This is a short video from Pomerleau Construction where they bring in IFC models into their GIS environment. They identify the location of IoT sensors that are embedded either in the concrete or in the construction site itself, so that they can understand environmental conditions of the construction site. So in the case of the sensors in the concrete, they know exactly the strength and the temperature of that concrete, allowing them to schedule the erection of the steel and the embeds at the right time, not too soon, not too late. And then the environmental conditions, they are monitoring for safety and the overall conditions of the construction site, ensuring everyone is in a safe environment. So IoT sensors in a construction site on the physical object itself, visualized using IFC information in a GIS dashboard. I would say this also qualifies as a digital twin. And then our friends over in the UK, Skanska UK Infrastructure, very much reliant on IFC information for a range of construction and design management workflows. This is really one of my favorite projects to show off. All of the road information is IFC information. They also combine it with a handheld survey tool called Survey 123, a custom user interface for collecting data out in the field with a map. They then, after collecting construction design risks and potential safety situations, water that might be standing that has an impact on the construction, they take that survey data, combine it into a dashboard, review this information. And again, all of the 3D information, all of the roads are based on IFC in this dashboard for reviewing construction design hazards across the team, ensuring the project kicks off with all the right levels of safety and understanding between the construction and design teams. So one more example from Skanska. This is another project where, again, they've combined IFC-based information generated in a range of BIM authoring tools brought into a GIS environment for a wide range of purposes, informing the public of where construction is going to occur, informing the construction team where they're going to focus on, allowing the team to combine 2D and 3D CAD and BIM information in a GIS view with schedule data so they can monitor and maintain the piling progress, pile driving, the inspection, and the ability to start constructing on top of those piles in this dashboard-like view. So just a handful of examples ranging from these little experiments that we've done of bringing IFC data from a wide range of authoring tools to a handful of customer applications bringing all of this content together. And with that, I will hand it over to my friend Marek.
Thank you, Mark. I'm just going to share my screen as well. Okay. Hopefully, are you seeing my presentation mode?
Not quite yet.
Which one are you seeing? Are you seeing just myself or?
We're seeing live PowerPoint. It doesn't look like you've even started the presentation.
So but are you seeing, sorry, I just want to make sure I'm seeing it in presentation rather than presenter mode.
Neither. We're seeing what looks like
Neither. Okay.
PowerPoint in edit mode.
Okay, we'll just see. How about that?
There we go.
So you're seeing the main presentation now, yes?
Perfect.
Yeah.
Okay, thank you very much. Sorry about that. I just want to double check that and see you can see my screen. Yes, hi, my name is Marek Suchocki, and I'm kind of here to take us back a step because Mark's done a fantastic job of showing the power of bringing openBIM data into a geospatial environment. And I think there's a fundamental message at the core of our joint presentation today that BIM and GIS are domains that have to operate together. And I know that buildingSMART as well as OGC are working collaboratively to better develop the art of BIM and GIS integration. So let me just step forward, and I need to share a safe harbor statement because some of the things I will present are still in a development mode and may change. So we wouldn't want you to make a buying decision purely based on what you're going to see today. But let's come back and talk about what constitutes openBIM. And this is as defined by buildingSMART. I'm pleased to say about 4 or 5 years ago, I was involved in the community that was drafting these terms. And we all firmly believe that interoperability is key to transforming our built environment sector. And of course, open and neutral standards are needed to help facilitate interoperability, as well as, of course, direct integrations, which I'll come to shortly. And I'll just come and talk about the final point there, which is sustainability is safeguarded by long-term interoperable data standards. And this sustainability, we're not really talking here about environmental sustainability as opposed to data sustainability. We need to retain our built asset data for many years. We may build in 1 or 2 years occasionally for certain projects, but those assets may be used for decades to come, if not over 100 years, particularly the case of infrastructure assets. So let's just have a look at some historic milestones. Ra at the beginning said that Autodesk was there at the beginning. And actually, we did our first example of interoperability using an open format by releasing DXF, which was kind of for drawing exchange format, way back in 1988. And to some extent, it's still probably the most commonly used CAD exchange approach. In 1994, Autodesk invited 20 other software companies to form an organization called the Industry Alliance for Interoperability, that a couple of years later became the International Alliance for Interoperability, where membership was opened up to anyone who was prepared to join and commit to helping develop what were called industry foundation classes, or open formats for sharing information. And the first version of that was published in 97, followed by version 2 in 99. And then, because the main focus for the delivery of the exchanged information was vertical or building based, and most importantly, because I even stumbled, the term International Alliance for Interoperability is often a mouthful. The name of buildingSMART was chosen, and the IAI name was dropped. A year later, IFC 2x3, which is really 2.3, was published, and this remains the most commonly used version of IFC. So in many projects today, we're still using a format that was published 17 or so years ago. 10 years ago, in 2013, IFC 4 was published, and this was an update to 2x3. And at the first infrastructure-related component of IFC was published in 2018, known as IFC 4.1, which was essentially an alignment. So the center of a road, the edge of a curb, or any other linear feature set. And last year, we were able to publish for the first time the full package of IFC for infrastructure called IFC 4.3. Let's talk a bit more about that in a moment, but I just want to talk about a direct partnership that Autodesk and Esri have had, where we realized that if we can integrate our different domains of data, we can provide huge advantage to our customers, and of course in the delivery of projects and management of assets. And perhaps the statement I really want to underline here is that openBIM and native workflows are not mutually exclusive. We need them both and leverage them in order to effectively deliver better infrastructure design and construction workflows. So just talking about why did we come together as a couple of large organizations? Well, we realized that BIM and GIS, as I said previously, they need to be combined for helping provide better authoring of design data and spatial mapping information, and of course creating documentation, which we need as contracts for our projects, to manage data during our projects, and improve collaborative workflows. So rather than operating in separate silos, we can have geospatial experts and designers and constructors working collaboratively. And of course, if we do that better, we can start looking at better analytics and insights and starting to leverage the power of technology. We often hear so many stories about the value of artificial intelligence for ourselves as members of society, but we want to leverage machine learning and AI in our workflows, and we can only do that if we have robust data developed during our project life cycles. And of course, this will lead to significant improved outcomes that our industry typically might suffer from poor performance. Let's look at improving that by better interoperability and integration. And if I just quickly illustrate what sort of form does this actually take? So this is actually an example of an InfraWorks engineer working in France. So let's call our engineer, she's going to be called Marie Claire, and Marie has just designed a bridge over a river, and she is very aware that her bridge piers may be intersecting with some subsurface pipework, but she's also aware that that data exists in a Esri ArcGIS environment. So she's using a direct connection. So this is a fully direct integration to pull the correct data sets that she needs in order to evaluate, is there a risk here? So She does now a connection and a refresh, and the pipework is brought in along with manholes and other features, and she can see that there isn't actually a demonstrated clash, so that sounds good. However, we have Jean here going out in the field, again using an Esri toolkit to do some digitization of missing assets, because for this project, somebody recognized that it looked like the original installer of the subsurface pipework had missed some of the assets. So Jean has now gone out and used the Esri field tool to digitize missing information and upload that directly back to the ArcGIS system. So that information is now available for other users. Marie-Claire, she's now been advised that this has happened, and so she can just do a refresh. So that connection she made means that she can pull some newly available data. And as we see in this illustration, there is now a clash with the foundations of that bridge pier, which, if that had happened during the construction phase of this bridge, would have been potentially disastrous, especially if this was something like a high pressure fuel main or a gas main. But because we know this information at the point of doing the design study, we can actually move the bridge pier, reorient it correctly to avoid any potential risks of a clash during construction. So it's a quick, simple example, but it really shows that BIM and GIS data need to be used continuously during our projects. So let's look at how we have collaborated with buildingSMART to bring integrations into open BIM workflows as well. So firstly, we have the buildingSMART International Organization, and I'm very pleased to say that Autodesk, we are represented steering committees for two of the key domains, namely infrastructure and the technical domain. And Mark has also joined the infrastructure domain, and this is our committee that was announced during the Rome summit that Mark referred to earlier. So we are composed of representatives from many different organizations globally, bringing different perspectives and also needs for the use of rich data during infrastructure projects. And as a community, we've worked together with the Railway Room to deliver what I mentioned earlier, which is IFC 4.3. So we focused on certain specific subdomain areas, such as bridges and roads, and obviously rail assets. We are also collaborating further to enhance the data model to include tunnel data, and there is a new project soon to be initiated about extending the waterways work as well, and there will be a number of other projects in due course. And again, I will immediately encourage anyone listening to please participate and join our community so that we get expert stakeholder views on how we enhance the schemas. But IFC 4.3 has been released. It was released, as I mentioned earlier, last year, and we're in the current process of finalizing certification approaches for software using IFC 4.3. That's for import and export. And also IFC 4.3 has been submitted as a candidate for ISO 16739 update. This is being currently reviewed through the standards community, and hopefully will either be approved as the 16739 latest version later this year, or more likely early next year. And once that's available, we can actually start specifying that in contracts. I'm delighted to say that Autodesk has had this long-standing commitment to supporting open standards, and particularly buildingSMART standards, and we support the IFC 2x3 I mentioned earlier in a range of products, and IFC 4 particularly in our building design toolkits. We were also, I think, the first provider to support the IFC 4.1, which I mentioned earlier, in our Civil 3D toolkit. That has now been deprecated as part of the IFC 4.3 work. And we also look to support other buildingSMART standards such as BCF, and we did a draft study around also the buildingSMART data dictionary, which will be something that we can look into in the future as well. So our development hasn't stalled there, because we recognize that having multiple point solutions for IFC import and export is not sustainable for ourselves. So we joined the Open Design Alliance a few years ago and are using their software toolkit in order to have a consistent library for our import and export within a range of our solutions. We've released some of the early solutions already, like Revit and Navisworks, as well as for our cloud tools, and we intend to enhance others. And the other value of working with the ODA, and I saw that Mark mentioned that Esri are also working them, is that ODA have also been one of the collaborative partners during the IFC 4.3 work and continue to do so. So let's have a quick illustration of what does this mean for users. Well, this is a rail model in Civil 3D, so fully designed in Civil 3D, and the Civil 3D user here has exported the IFC of that design, and now we have a Revit user who can directly import that. So all the information is fully available, all the parameters, very similar to something that Mark showed earlier. And a Revit user now who might have historically struggled to get a civil engineering design into their toolkit is able to view and enhance and augment the model with the features and functions that a tool like building design tool like Revit is very good at. Here we're doing some documentation changes. We've added some further foundation information. We can actually add some drawing information because obviously we still need to create drawings on our projects. And we can also add things like stations, which is what a tool like Revit is perfectly designed for. So civil engineering tools need to be used for civil engineering design, and building and structural design tools need to be used for that. Not only can we obviously share between authoring tools, here we've imported the self-same IFC from the Civil 3D model into an Open Design Alliance viewer. So that same model is now being shown along with all those parameters in an open toolkit. I just want to also make a comment that, when we talk about openBIM, whilst we are on a buildingSMART webinar, I do want to emphasize that there are many other open formats. Mark talked about the OGC, and they have a number of very powerful exchange formats that we need to leverage in our projects for the appropriate data sets. And I really do encourage everyone to make sure they use the right formats for the right activity and process, because some things are more or less applicable to various workflows. And of course, you can still also leverage native exchanges where appropriate. So if you'd like to find out a bit more, of course, you can look at some of the Autodesk resources that are available. But also, as I said earlier, I do encourage you to come and join us in the buildingSMART infrastructure domain efforts. And the links are shared there, but just if you go to buildingsmart.org, it's very easy to navigate. So with that, I'm going to end my presentation and hand over to David.
Thank you, Marek. So let me share my screen. Okay. So what I'm gonna do is a little bit of summary and show one way of doing a workflow to move the data from Autodesk into GIS. So the goal is basically to showcase the integration GIS and BIM. So first of all, we have InfraWorks model. I'm not a bridge designer, so don't think that you will be able to drive over this bridge. So we have basically the piles, the cross frame in the InfraWorks. So what I'm going to do is basically export that InfraWorks model into Civil 3D, which is basically, we have here our model in Civil 3D. Sorry, my panning is not working. Okay, so here's our bridge. Basically comes with the terrain. I added some stormwater to the line. So we have two ways of visualizing this. From the InfraWorks, I can go to the Revit side, or I can go to the Civil 3D side. And I forgot to open Revit. That's fine. So you get the attributes here. You can do, you get the input data for the bridge. You can do your civil design in Civil 3D. And then you can export it. One thing that I want to point out, and basically to reiterate Marek's comment, is IFC started as for buildings. So that's kind of the core, how it started. But now we're moving toward more the infrastructure, so bridges, tunnels, roads. So there's still a few things that when they're exported into IFC, they don't really fit the design, so we have to kind of lump them into different categories. So sometimes you will see that one element, let's say for example the bearings here, you will see in a little bit that when I exported it in IFC model format that doesn't have that, so they were gonna come as proxy element, as building proxy elements. So just to reiterate that, so we have here our Civil 3D model. So we can export it to IFC. There's ways that you, from the Civil 3D perspective, you can customize the export, but not gonna go through all that. There's a JSON file that you can modify that allow you a little bit more control on how things get exported. So I generated the IFC file. So I generated one from the Civil 3D and another one from the Revit perspective. So this is the same scene that Mark showed at the beginning. So this is Columbus, Ohio. We have imagery from 2021. Here we have imagery from 2009. So you can see that they did some improvements on the Scioto River. So we can bring now, I bring in LiDAR data. I've also brought the OpenStreet data. All this data is open. The LiDAR data is coming from USGS. The 3D models of the buildings comes from OpenStreet. So now we're gonna look at our models. So let's start with the Civil 3D. It's just gonna take a second to draw. So there is our Civil 3D. And we go a little bit underground. And we got all the elements. That's gonna kind of, so let's look at the abutment. We got the information. So we got the attributes that were coming from the Civil 3D side, as you can see. We're gonna turn it off and let's open the Revit side, which is gonna take a second. Okay, let me close this. So this is basically now is the Revit side, same abutment. We're gonna see that basically now the way that things get exported between the two softwares it's a little bit different. So you need to understand how each software is placing the data into the IFC. But if you look at basically same attributes that you get from the different side, the only difference that I will have here that I'm going to showcase is I'm a more Revit person. So I was able to add some railings to the drawing. And if you look here, we click at the railings, that is not on the Civil 3D side. This came directly from the Revit side when I exported to IFC. And here's all the attributes that you get from the Revit file that was converted to IFC. After that, you get all your information on your scene. Then you can go and, as Mark showed, here's the scene with the data. I only published the IFC file that came from the Civil 3D. We can go here and we can look at the bearings, and there's the attributes that came out from the Civil 3D data. Now, you can basically, the way that it was done, it was published directly. But there's ways that you can do a little bit more massage the data, so it fits a specific schema. So for example, if I'm on the DOT side, I would like things certain way. I want to carry certain attributes. So then you can now leverage the GIS side and massage your data to fit the schema that you want for your CMS system if you're gonna track the assets. So that's kind of the last step that you wanna do. Now you're here on a viewer, you can have different tools that you can do measurements, you can do a slicing. So let's do a vertical slice. We can go that way. So you can see basically here is, we can see the cross framing of the bridge. And if we click on it, and it's gonna give me all the information for that steel. So that's one workflow. There's other ways that you can deviate a little bit more. Also, you can now integrate in these workflows the clouds. So using Autodesk Cloud Connection, Construction, sorry, and ArcGIS Online to basically tweak the workflows depending on your needs. Mark and Marek.
Very good. You kept us honest with a live demo there, David. Thank you. There's been several questions coming in that myself and Marek have been answering while you've been talking, David. Really good questions. And some of them we've answered, some of them we've left open here for the last 15 minutes or so. I might just try to moderate some of them if you don't mind. Maybe the last one or two we'll start with. Do these tools import or show IFC zone, IFC system, IFC element type, and perhaps also next question, IFC bearing and IFC bearing type? So maybe it's a specific question, maybe it's a general answer as well.
I can answer that one. So from the IFC side, if you move the file to Revit, Revit gives you a little bit more flexibility using their UI, where you can define the type, how you want to export them. If you go through the civil side, you have to modify a little bit a JSON file that will allow you to customize it that way. But both, basically, you can handle that. For the IFC zone, that's more building related than bridges or roads. So I don't know on that side.
Okay, Marek? I don't know.
I can't answer that technical question. It's quite a detailed request, so I don't want to make sure, I don't want to give a false response to that one.
Yeah, Nick, you've got my contact info if you want to follow up.
Nick, you can always hassle me on that one. So. I saw a question actually from Christian Frey, which was about the quality of data, and that many of the data are provided by third parties. How do you make sure you get good data that you can work with? Well, I'll give a very simple response to that. And I think this is actually, we need to also adopt good working practices. And I'm a huge advocate of ISO 19650. And it's interesting that Nick Nisbet's one of our commentators, because he and I have been instrumental in driving the development of information management standards such as 19650. And it really comes down to first having good information specifications and requirements, and then also planning the delivery of information through the different actors and phases of the project. So you get the right data at the right time by the right person, and you manage the quality. So this isn't really an issue of anything to do with design softwares or geospatial software tools, or even openBIM file formats. This is actually about really getting down and planning your projects correctly, so that you don't have to rework or modify data when you receive the wrong stuff. So really encourage everybody to adopt also ISO 19650 in their delivery of their projects.
And I'll maybe elaborate on that as well, and might get us to one of the other questions that was asked about level of detail and scale. I think there's some misperceptions that the information you might use or access in GIS is limited to satellite imagery, where you're, at best going to get, 30 centimeter accuracy, or you might only have fixed wing imagery, which is a little bit more accurate. But the quality of the information that you collect, the workflows that you put in place to ensure that your your reality captures are coordinated and aligned and on the right coordinate systems and using control points, yeah, it's not really an issue of the platforms being, creating bad content. It's the workflows around that you, and the expectations you have. Don't plan on having sub-centimeter accuracy with satellite imagery. Fly some drones, fly some helicopters, do some terrestrial-based image collection, and combine that with the other sources so that as you zoom from city level down to the front door of a building, GIS allows you to turn on and off those layers based on the scale in which you're interacting. So that's maybe a general response to some of the questions. I do want to try to get as specific as possible to Zhao's and I think Andre's questions, that there's problems related to different scales, LODs or LOINs of different projects. For example, the terrain is in scale 1 to 5,000, the building is in scale 1 to 100. Will there be some issues? No. Maybe my answer that I just gave addresses that. Is there anything more to elaborate on that, Marek or David, do you think?
No, I don't think so. I think it's...
I don't think so.
Okay. Very good.
I'm just going to quickly respond in the text to Arcady Thompson's question about joining the US team. I think, I'll type it in, is please go to buildingSMART USA. The information is available there. They have different levels of membership. And, anyone on this webinar who isn't yet a member of their local chapter or participating in the buildingSMART International Domains, we really do encourage as many participants as possible, because this really is a case of more the merrier, particularly people with expertise in areas where projects are being developed.
A couple of questions here that I'll try to answer and have a little conversation about it. Typically in a BIM application or CAD application, you're referencing your project based on lower left corner being 000, which is somewhere off the coast of Africa at the equator. That is, one of those situations, garbage in, garbage out. However, both on the Autodesk side and the Esri side, we do have tools, functionality for transforming those models to appropriate coordinate systems. So, the best workflow is to start off with a properly referenced, properly geo-referenced project before you start putting lines, walls, roadways, center lines, whatever it might be, on your paper, digital paper. But if you haven't done that, there are tools for properly transforming those models to correct geo-referencing. I know that's a question that comes up quite often.
Yeah, Rod, do you know if we've got any other questions or anything else that has come through to you?
Hi there, Marek. You talked about how your work has moved to version IFC 4.3. Could you just highlight the differences between the versions and what that's been like to move over?
That's an interesting question. Yeah, so IFC 4.3 is extending the existing data model to include infrastructure information, and in some cases just enhancing and improving the previous, say, building focused data. So I don't want people to think that IFC 4.3 is in some way radically different to IFC 4. It's not. It's actually just an extension of that, because as we use IFC in practice, in projects, we obviously do identify if there are some shortcomings. And the reason we set up the infrastructure room, as it used to be called, was because people like myself, I'm a civil engineer, we were frustrated that actually the value of IFC for infrastructure projects was relatively limited. And so we brought the community together in order to add those missing infrastructure assets. And we definitely know that there is more work to be done, but we focused on what were discussed as being priority areas, namely road, rail, bridges, and shared civil assets that can be used in a large variety of projects.
Thank you for that. Can you also provide any guidance on usage of IFC?
Aimed to myself or to all three of us?
Anyone who would like to answer.
Guidance?
I think I'll go back to
more of it.
Go, Mark, if you want to.
I was going to say, use it more often. I recently had the pleasure of being at a conference in Germany and was really impressed with the adoption of IFC, the expectation of IFC to be the language, the interoperability language for infrastructure projects. becoming much more standard, being mandated by government agencies. In the US, we're still a little bit behind, as we have been for decades, but I do think we will catch up for a number of reasons, specifically around infrastructure. Guidance of them, I'm not sure if I can give much more than just a very vague, use them more. The reliance on them for mission critical projects around the globe is real. So I'm not sure if there's really any, there certainly are, challenges with any format, with any application, with any data exchange. But I think we're at a point now where the data is trustworthy and is highly usable and highly valuable.
Yeah, I mean, thanks, Mark. And I'd also add that, going back to my previous statement, to get the value of IFC in project workflows is to adopt standards like ISO 19650, so you fully plan the work, but you also understand data deliverables. And this really is an obligation that we need to encourage our project clients, so the road authorities, the rail authorities, and of course, building asset owners to understand the value that IFC can bring to their asset operations and decision-making, and also any kind of analytics and insight into the information they receive. IFC is not a magic bullet. It needs to be used in the appropriate way, but the more people can derive value from IFC handover in order to, let's say, populate asset records or to maybe carry out cost management workflows, then IFC will get increased adoption. And of course, then the feedback can come to software vendors such as ourselves and many others to add perhaps missing functionality, or it's actually not a software issue. It's actually, let's extend that data model to provide the features and functions that people need in projects and asset management. But it's really a case of make sure you plan first and foremost, and don't presume that IFC is going to fulfill a feature or function. You need to understand what it can do and also perhaps what it can't do.
Thank you both. That's really helpful to clarify. Another question on what the investments from each of the companies that are being made and what you think their future looks like looking ahead.
I'll start
well, I mean, I think from my side, I stated up front, we've been there from the very beginning, and we absolutely intend to continue our support to buildingSMART and the wider development of open standards where appropriate, and of course supporting them in our products. We actually have a huge program underway to extend our IFC import and export within a range of our tools, and supporting further buildingSMART schemas like BSDD. I think IDS was raised there. Yes, it's all on our radar. And so, we absolutely want to get user feedback to develop further what we've already got, but also add further functionality.
Yeah, I have a lot of the same responses. I'd maybe start with an anecdote. Marek showed on his slide the International Alliance for Interoperability forming in 1994 at Autodesk. I was actually at that meeting. Helped set up the room, I recall, and was blown away by the idea of these competitors getting together to talk about interoperability way back in the day of CAD. When I joined Esri about 3 years ago, as I've mentioned numerous times, one of the very first things I did was reach out to Ian Howell and say, what's the best way that Esri can become involved in here? If we want to be a strong player in the AEC industry, I know we need to have a strong position at buildingSMART. So we now are multinational members, which means Esri Inc. and many of our distributors are actively involved. We've literally got dozens of people across the company, from development, product management, product marketing, in sales roles, who are very active participants in the various domains and rooms and committees and working groups, attending the summits around the globe to have our voice heard and to hear about progress. And like I said, we are, already within at least the development environment on 4.4 Addendum 1, and working closely, as was mentioned, with the ODA. As those libraries get completed, we incorporate them to our development process. So I would only expect our investment, our interest to increase as IFC becomes more important in our industry. David, you're involved in buildingSMART US. There was a question, actually, does the US have a similar committee or a similar structure you might be able to talk a little bit about buildingSMART US and what you do there.
Yeah, so yes, we do have committees for the US. So we have several groups. We have one for digital twins. We have one for the BIM and GIS integration. We're starting one for healthcare. So that's kind of a little bit new. But so we have depending on the group, monthly calls, we go through it and try to promote IFC through the community. We try to do some webinars, gather requirements. So, because sometimes there's a difference between what the Europe and Asia is doing versus the US. So we try to basically gather the requirements that the US needs in relation to how we can leverage the IFC in the US. So try to make it a little bit more popular so people understand how they need to use it, what are the benefits, why we will use it. So if you have more questions, just email me and we'll add you to the list, and maybe we'll just send you the invite for the next meeting. So that way you can start looking and see how you participate and how you want to get involved with the community.
And whilst I've got an opportunity, I'd like to make a big shout out for the buildingSMART UK and Ireland chapter, on which I also sit on the steering committee. We actually mirror the domains wherever possible. We have representatives there, and I'm very pleased to see that our chair, Casey, is on the call, as well as our vice chairs of Nick Nisbet and Emma Hooper. So you know, we really do encourage the audience to join your local chapters and, if possible, participate in the activities and you know, get involved.
Thank you, Marek.
Basically, we just started. So from the US, we just started. So we're still small, but we have a very engaged group. We just want to reach more members of the community. So join, please. If you have questions, feel free to email, and we'll help in any way we can.
Thank you all. I've just launched a poll for our attendees, so it'd really help us out if you have time to answer that and just give us any feedback. That would really help for our future webinars and see where to direct our attentions from here. I would also like to point everyone towards our upcoming summit in Lillestrøm in Norway from the 18th to the 21st of September. So if you haven't already seen that, do check it out and come and join us if you can. Otherwise, just get involved in our community as well. I'd like to take this opportunity to thank our presenters today, to Mark, Marek, and David. Really helpful insights and showing all these examples. There's been lots of great questions, so extend our thanks from everyone. Great presentations, and we look forward to what the future holds.
Hoorah. Thank you, buildingSMART.
Yeah, thank you, everybody.